what if I took NH4NO3, okay, ammonium nitrate. Okay, ammonium nitrate is a soluble salt. So it'll immediately break down into ammonium ions and nitrate ions. And there wouldn't be any of this left. See how I'm making a single arrow there? Okay, so what I want to do is see if ammonium ions or nitrate ions that just formed will react with water. Okay, the nitrate ions, if they did react with the water, do you know what they'd make? HNO3 and hydroxide, right? So the H is coming off there, goes like that. Okay, yeah. Oh, thank you. Okay. All right, so strong or weak? Okay, that's strong. So will this happen? No, it would immediately break down into hydrogen ions and nitrate ions. So that's not going to happen. There's no hydrolysis with that. So anytime the ion reacts with water to make a strong acid or a strong base, there would be no hydrolysis. So you could say that this is the anion of a strong base, or sorry, of a strong acid, and it does not undergo hydrolysis. Okay, now what about this NH4 ammonium ion here? Okay, if you put that in water, can you figure out what that would make? What do you think, Connor?
NH4OH.
Okay. And then that would leave a hydrogen ion out there, right? Okay. Now is this one strong or weak? Okay, this is weak. So will that break down 100%? Okay, it'll hardly break down at all, right? It's a weak base. So it's mostly going to stay as molecules. So it's a weak base. Stays mostly in this form. Which means it's removing hydroxide ions from the solution, from the water. You had pure water and then you put this salt in here. This is taking hydroxide ions out of the water, and you're having just the hydronium ions there. Okay? So now there's going to be more hydroniums than hydroxides in the water since it's making these. So I'm going to say it's adding hydronium ions to the solution. And that means that this is acting like an acid, right? This ammonium ion is acting like an acid. It's making hydronium ions in water. So this right here is the cation of a weak base. And it acts like an acid. Undergoes, I hope you guys aren't writing as big as me because I was going to do a whole nother example here. Sorry. Too late to tell you that. It undergoes hydrolysis to form H plus, or really hydronium ions, and an acidic solution. I'm going to make another example up that you guys can either squeeze in there or maybe write it up there on top. Okay? So even though that one doesn't undergo hydrolysis, this one does. And so if you dissolve ammonium nitrate in water, you won't get a neutral solution. You'll get an acidic solution. Okay? Does that make sense? All right, let's do the AlCl3 that I have down there as my second example. That would break down 100% if it's soluble, which it is. Okay, now maybe we can start skipping a little bit of steps here. Well, let me start with the chloride. Would the chloride ion react to form would it react with water? Okay. If it did react with water, what would it make? It would make the strong acid HCl. and it would immediately split, which means basically it does not react with the water. Okay, so since this is the anion of a strong acid, it does not undergo hydrolysis. Okay, anion of strong acid, no hydrolysis. So you don't have to worry about that one. You could just skip writing an equation for it because it doesn't really react with water. What about this aluminum? If this aluminum reacted with water, do you think it would make a strong or a weak base? Okay, so we're going to try to do that. There's two ways. You can take the aluminum plus the water. Oh, I forgot something up here, you guys. This should be a double arrow. Because if they make a weak base, they make an equilibrium. Okay. All right, so up here, I have my aluminum and it reacts with water. So this is going to be like this. There's two ways to do it. You can either just take one hydroxide and put it on there at a time. That's just how we learned it first. And then have the hydrogen ion out there. Or you could do it the way it really is. This aluminum ion is really hydrated or surrounded by water molecules, and it turns out it's surrounded by 6 of them, and it makes a complex ion. You guys remember the name of that? Yeah, hexa, aqua, aluminum ion. Got a lot of A's in a row there. Okay, and then that would react with water. Do you remember how to do the other side of this? Anybody want to try it? You want to try it? AlH2O taken 5 times and OH. Okay, sometimes they put that in parentheses and sometimes they don't. Okay, and then the charge would now be +2, just like this one. It's just that you're showing all these water molecules that are around it. Might as well put the name on it. Remember what it would be? Oops. Not hexa, but penta, aqua, hydroxo, aluminum ion. Okay. Plus, you'd have your hydrogen ion that would hook onto the water, and you'd actually have a hydronium ion. Okay, so that's what's really happening. Okay, but you could also do it this shortcut way and get the same idea out of it. Okay, but the point is that this ion right here, this aluminum ion, either way you want to show it, is the cation of a weak base. Because when it makes a base on the other side, the one it makes is weak. Okay, remember the strong bases are from metals in groups 1 and 2, except for beryllium, and then the transition metals are all weak bases. Okay, so that's the cation of a weak base, and it undergoes hydrolysis to form, it forms that weak base and hydronium ions. So it's forming an acidic solution. Okay, now this might be a little confusing. This is the cation of a weak base, but it is an acid. Do you see that it's acting like an acid? Because it's reacting with water to make hydronium ions. All right? Okay. So if you take a solution of a salt that was made from a, I should say, that was made from a weak base and a strong acid, then you'll get those things. I probably really should have said it's the cation of a weak base and anion of a strong acid. Okay, let's try another one. Can I take this away? These poor people trying to watch this thing, they're not gonna have a chance. Okay, all right. So, let's see. Solution of a salt of a weak acid and a strong base. Okay, and again, I just mean made from. I don't mean it has those things in it. Okay, so let's say we're doing this one right here. NaClO. Okay, so this would be dissolved in water, be 100% broken down, so it would make sodium ions and hypochlorite ions. Okay, will either one of those react with water? Will sodium ions react with water? If they did, what would they make? NaOH. So will they react with water? No. Okay, if they would make a strong acid or a strong base, then they don't react with water. Okay, so this one, no hydrolysis. Well, okay. Wow, there's like a delay. Has it been doing that the whole time? Yeah. Oh gosh, that's going to be really confusing. All right, so there's no hydrolysis for that one. Okay, so there's no change in the hydronium or hydroxide ion concentration because of that. Okay, but this other one, the ClO minus, the hypochlorite ion, that one will react with the water. So double arrow that one. All right, and that's going to make, can you figure it out? HClO, it makes the weak acid and hydroxide ions. Okay, so is this thing acting like an acid or a base right here? Base. But it's the what of what? It's the anion of a weak acid. It's an anion of a weak acid which undergoes hydrolysis. And then it makes that weak acid, right? And makes it to make a basic solution. Okay, so the reason this works is when it makes this HClO stuff here, this is a weak acid, so it's going to stay as molecules almost entirely. So it's like removing hydrogen ions from the water solution and just leaving hydroxide. You guys getting the idea? Okay. All right. So that's why that one would happen. Okay, then let's see. What about CaCO3? Do I even need to do that one? I probably should. I don't know if I have it on here. Okay, will either of these ions undergo hydrolysis? Okay, not calcium though, right? Because calcium would have made calcium hydroxide and that's strong, right? Okay, so it'll be the carbonate ion. And that would react with the water. Okay, can you figure out what the other side would be? HCO3 minus 1, see it's going to pick up one H from there, and hydroxide. So this one's acting like a base. So this is going to make a basic solution. Because this is a weak acid and it will stay mostly in this form.